Hello and welcome back to my Java tutorial series. Today we're working on episode 6, and as always you can see our finished product from the previous episode, which was about loops and the ternary operator. Let me just start up a new project for episode 6. We're going to be working on concepts of object-oriented programming that of course are essential, as Java is an object-oriented programming language. Today we'll specifically be handling what is an object and what is a class if we get time to, but that's pretty easy. And since we're also talking about objects, we're also going to be talking about the object modifiers you see, such as static, and you'll also be introduced to public, private, and protected, and maybe return types. But either way, let's get started with our main class. So here's our main class. We'll just put in our normal method. We'll set void main string array args. Okay, so that's the basic setup of this class. Now, what is an object? Now, we have dealt with objects before. There are objects such as the integer, which all the primitive data types that I showed you before are special types of objects, which means you can set them to a literal. So you can set that to 2. Then you also were introduced to strings, which are special types of objects that you can also set to literals. Seeing, you can also set this to a literal. Of course, you can also set it to the way to where it is a new string, because string is an object and it extends object. Crap. So there. Now this method here is how most of your things will look with objects. Most of the time it'll just be the modifier, such as whether it's public or private or protected is the first one. If you don't put anything, like nothing like I have in the previous episodes, it's by default public. And then static, which is either you put it or you don't. I'll explain what that does later. The type of object it is, which this type of object is a string, the name of the object, and then you could like just put, you could just, instead of setting it right there, you could just set it right there. And for any object, for anything that isn't a primitive type, for anything that is an object, if you don't declare it, then by default it's null. So right now, since it's null, which on most other programming systems or other operating systems, null or nil is basically it's nothing, it's empty, it's you haven't set it yet, can't use it yet, or else you'll get some problems. So if we try to print out string 3, we should get a error, and the error should be a null pointer exception. Oh, well, it printed out null because again, string is special. It printed out null when it was null. So yeah, but normally if you try to do something else, so those are basic objects. Now in the Java API, which is, Java as a programming language comes with a vast amount of API or application programming interfaces, which include several things that you could use. Now, so we could use a wider variety of objects, we're going to go up here in between your main class declaration and your package name. There's a keyword called import, so you can import things from either the Java API or other APIs you're using, or any other thing that's actually like in your project area. So right now we're gonna import java.auth, and auth, one second, I need to remember what auth stands for, because I don't want to introduce you to auth if I can't tell you what it is, which it's kind of late. But okay, well, java.auth, I'll get on looking at what it means. Okay, so java.auth basically holds a whole bunch of things graphics wise. So it lets you draw things that, okay, it stands for Abstract Window Toolkit, okay? Abstract Window Toolkit. It contains a lot of things for, like, drawing. Now, we won't be drawing anything to the screen today, as we're just using these objects as an example, but if we were to, like, create a window, and we could draw things into that window, which we'll get to soon, but basically now we can do public static rectangle rect1. That should work, because we imported java.ot, which contains the rectangle. If we took this out, we don't have access to that, and it's like, hey, what's a rectangle? We can't find rectangle anywhere, so we're like, either, you know, import rectangle from java.ot, which we did, or, you know, create it. So basically what we can do is, what else we could do? We could do import rectangle specifically from java.ot, and this imports only rectangle, but if we put an asterisk there, that means every single thing in java.ot we can import. So there's a rectangle, and what we can do, we can set it to a new rectangle. I don't think there's an empty thing. Okay, you can. But normally with a rectangle, what you can do is in here, in these parentheses next to when you're declaring the object, you know, you say this is the type of object it is, the name, then you say new, since it's a new one, the type of object again. Sometimes these things won't be the same thing, but most of the time they will be, especially in the beginning. Then the parameters for what this rectangle is. So right now, the constructor for a rectangle is the x-coordinate on the screen, will go 0, the y-coordinate on the screen, which is 0, the width of it, which will go 100, and the height of it, which will go 200. So that's a basic rectangle. And if you go over here, you know, when I originally said it, there was nothing in it, and all it showed was this. But if you hover over it and have the parameters, it tells you what the parameters are. So, you know, x, y, width, height. So there you go. So that's a new object. So another thing we can do, to better explain this, I'm going to the first time, doesn't really matter that much, but I'm going to make another class, and we'll call it Rect. And then we'll make another class, and we'll call it Triangle. Actually, no, that might already be taken up. We'll just call it not main. Okay. So now we have 3 classes, and they're all in the same package. But now this will help us better differentiate between the different modifiers you can have. For this rect, we're going to import java.ot again. No big deal. So basically, you know, these objects, such as the rectangle, are declared in the API. So I believe if I can just right-click on it, show declaration. No, nothing really. There. So this is rectangle class as it is in java.ot. Now, whenever you look at any of the Java source code, you're going to see a whole bunch of this blue stuff, which will also go in this episode. It's called JavaDoc, and it helps you document your code so people can know. So basically, all this stuff here is what shows up when we hover over a rectangle. That's how the IDE. And so it has a public integer x, a public integer y, width, and height as along, which is a serial version UID, which on serializable objects you want to have one of these. I mean, normally it doesn't matter what it is. Normally you always set it to 1, but it doesn't matter. We'll eventually get there. It's a private static native. Don't know what native is. That's new, but I'll soon look that up. Okay, but yeah, here's a public rectangle. So this is an object declarer. So whenever we create a new object, so let's say rect, now we'll come across something new, which is extends rectangle. So what happens, since we extended rectangle, we're also getting blue here because it needs to be serializable as well. So we can add default serial version UID. So now we have that, so now it's just going to be safer. So basically, we extended rectangle. So that means every single thing, every single variable that rectangle had that is public or protected, we now have, didn't want to do that. We now have in here. So we can access, you know, width equals 1. This, what do you have? What's wrong with you? Let's put this. Oh yeah, width is not static. My fault. Wait, never mind, that shouldn't matter whatsoever. Oh yeah, because when you're setting something, it has to be in a method. So basically, let's do something. Public rect, we're setting up an identifier for this. So basically, rect, this is how it happens. Like, okay, sorry if I'm not being clear. In rectangle, you see right here, we're declaring it with 4 parameters. If we looked in rectangle.class, we'll see if we go down to their public rectangle, this means no parameter. So if you enter rectangle with no parameters, it enters this, and when you use this in a method, it calls this same exact thing, but which actually has parameters defined. So if we go to public rectangle, you can pass another rectangle as a parameter, and it'll just create another rectangle that's exactly like the previous one. But we used this one, this public rectangle, x, y, width, height. It sets this dot x to x, this dot y to y, which is the name of the parameters. See what it's doing? It calls this dot x, which means this class, the x that is contained within this class, which happens to be up here, not all the way up here, but this dot x is what it calls, and it sets that to the x parameter that it is receiving from what you declare. So I went down way too far. My apologies. So we just go down, back down, so to the x, which is also the parameter. So that's how you differentiate between what x you're referring to. If like this x had a different name, then you don't have to put this in. But basically that just declares it. So basically that declares the rectangle. So if we went into here and say rect1 dot, we're open to all the things that rectangle has. But let's say we wanted to have a rectangle, but internally we wanted it to have an extra method, which I still have to go over what methods are. Of course, this is a great episode for it. So this rectangle, we're going to do super. Super does not mean it's amazing or extraordinary. When you call super, it means whatever you pass into this, that means it passes into its parent. And its parent is rectangle. So if we do super this, basically, we can put super this, which means since the public rectangle in this that has no parameters is this, that means whenever you create a rect, so if we went over here and made a public static rect2 equals new rect, that means it's going to be the exact same. That means the first thing it's going to create, it's going to go to it set as soon as it, what the hell? As soon as this calls new rect, it's going to go into rect, look for its method here. That's just the declaration method. It's going to look inside it. It's going to go to super. Then it's going to go to its parent rectangle and look for the method with those parameters. Then it's going to go here. Then it's going to go here and inside rectangle. Since it says this, it's going to be inside rectangle and look for the declarative that has these 4 parameters. Then it's going to go here, and then it's going to set all of these. Which basically, setting all of those makes it so we can use all the other things that rectangle provides to us, such as get x, get y, get width, get height. There's also a set for all of those, I believe. Get bounds 2D, set bounds, etc., etc. It is a very long class, as are many of the Java source code ones. So that's the only real special thing about it. Now we extended, in this example, we extended something in the source code, but you can always make your own class that doesn't extend anything. So basically, when we do this, that means super isn't going to work. It doesn't have a parent. And also, this is yellow because we don't even need it, because it's never used, so we can get rid of that. Also, this import is never used, but we are going to use it. So basically, calling super on this won't do anything. I mean, whenever you create a class, it by default extends object. So you're not getting an error because technically this class extends object. And object also has something else. But we don't want it to be an object. Let's say we want public integer x. And also you can declare variables on the same line. So we can just do that. So it declares 4 empty variables. And what happens? We can do rect integer x, integer y, integer width, and integer height, if I can spell it right. So we're going to do this dot x equals x, this dot y equals y, this dot width equals width, and this dot height equals height. So basically, we copied what the rectangle has, so we're making like our own little rectangle thing. So then what we can also do, just as an example, also so I can teach you methods, let's create a method. And so right now, this method is going to be public. Public means that anyone from anywhere can can use this. Public. Let's do public integer. Public integer. Integer means the next thing after you put public or static. Sometimes you can put static, but right now we don't want to get static. Public int means this is going to return an integer. So whenever you use this method, it's going to return a type of integer. In methods, you can return any object. So actually, let's make it return a rectangle. And then the name of it will be getRectangle. And yeah, we're just going to set it like that. So this method is a public method that returns a rectangle. This is red because we haven't made it return a rectangle yet. So we're going to say return new rectangle. And we're just going to set, x, y, width, height. So we made our own pseudo rectangle class that has a method that can make you return a real rectangle. So let's just say a new rect 0, 0, we'll make it the same as the last one. So now we have a class that has a method. Now another thing we can do is we'll just make but we're gonna make this one static. So we're just gonna do public static. We'll return a string. Get description. And this is like completely unnecessary, and you would normally never do this, but for the sake of stuff. And since string is a literal, we don't have to say return new string, we can just return a literal. Okay, so yeah, static. So the difference between the difference between not static and static, well, in order to get that, we have to go to a different class, which is why I made different classes for this. So what we can do, we'll just make we'll change that to rect3, and we'll just make a new rect. And that rectangle is not declared. Now we'll do rect2 equals rect3 dot get rectangle. Notice how we're calling the method from the object, not a class. We're calling the method from an object. So if we just made it print out rect2 dot get width, sure, why not? Basically, it's going to print out the width, which should be 100.0. Apparently it's a float. Let me double check that. It's not. I don't know why it's saying 100.0, but I guess that doesn't matter. So yeah, it's actually, if we go into rectangle.class and we go into the other constructors, Okay. Doesn't matter. So basically, it's printing out 100. Another thing we can do is that, how about string 3, since we already initialized that, equals rect dot get description. And if we printed out string 3, oh, the hell. It wouldn't make sense. No! Stop! There we go. Okay. So it's going to print out string 3, and of course it's going to print out the description that we told it to return. This class is a pseudo class for java.odd.rectangle. So, notice how we're calling getRectangle from an existing object. So that means if we try to do this and call it from the class rect, if we try to call getRectangle, we can't. It doesn't even show up for the autocomplete option. So since this isn't static, that means you have to have an existing object to use it. If it is, and so yeah, you can't call it directly from the class. If it isn't static, if it is static, then you can and should call it from the class and not an object. If you try to call it from an object, the IDE will just give you a warning and say, static method should be accessed in a static way, which means using the class name. So that's mainly used for, like, if you made this static, that means you could, getting coordinates from the class doesn't make sense, because normally every different rectangle object will have different dimensions, so you want to get the dimensions from the specific object as opposed to getting it from a class, which would be completely redundant. But then again, you don't want to get the description from Rect 3, because getting it from different objects is kind of redundant as well when you can just call it from the class. Since every single object you're going to get it from, it's always going to be the same, so you might as well just call it from the class. And that's static. Another thing we could do is private. Let's make all of these private. So private means you can't access them from another class. So if we tried to get, we'll just make them public again real quick, just to exemplify what it is. So we can call system.out.println rectangle2.x. Actually, I think that's only working because rectangle 2 is a rectangle. We want to call rectangle 3.x. So that means x is public, and it's not static first. That's why we're accessing it from an object, because it's not static. And also, so it's calling the x coordinate, but actually, to make this better, we might as well get width so we don't get just 0 in return. So now it's getting 100. So that works. But if we were to set this to private, which means only this class, not even children of this class, can access it. Only this class can use it. It's saying, hey, we don't know what width is. We looked all throughout Rect 3 and we can't even find it. That's because Rect is hiding it via private. Now, real quick, let's just make not main extend Rect. Extends. Okay. Okay. So basically, we need a constructor. Auto-generating it makes it look like, hey, what the hell? So basically, there we go. Not main. I know, it isn't a very ideal name considering it is going to be a rect. But it extends rect, which means you can call the parent to establish it for you. You don't have to, but you can. Just to make it different, we can add a string. And we'll call it string original. Right here, we'll just add a private string. And we'll just say, in addition to establishing the coordinates and width of this box, we'll say this.string equals string. You don't have to do this, but it's adding some variety to the child. So basically this works, but in rect, it's calling super because, It just goes to super. It goes, hey, you're declaring not main. Let's go check the parent of it. Oh, the parent's rect. Let's go check out what rect is doing. Okay, let's use this constructor for rect since it works. If we tried instead doing the constructor and doing this, which would work, which normally would work, but it's saying, hey, where's this x? Oh, well, this is saying this. Yeah. Where's x? We've looked all throughout this class and we can't find x. I mean, if we set this to public, this would work. It would also make this better. Well, why do I need a super? No, I don't know why I would have to include a super. But let's just make some ridiculous thing that just makes it easier on us. Okay, yeah, that works. So now not main works. Super doesn't do anything, but since it extends it and rect needs to have a constructor and it needs to call it super, it wanted that, so who cares? But now it customly sets it. So now even if we did change this to not main, maybe if I'm trying to also give you an example of something else. That doesn't work either. Doesn't matter. Okay, so now it works. Not main. Oh yeah, because we don't have a constructor for it. We also need to add a string. That'll work. Ta-da. I think we could also have this as rect. Yeah. So we're declaring a rect that is of type not main. You can only do it because not main extends rect. But, we don't want to do that. But, yeah, we don't want to do that. And that's all you need to know. So it does the exact same thing, and since get rectangle is also public, since this extends rect, it automatically gets that thing. So even though this is a not main, since not main extends rect, it gets everything in there that's public and protected, which means get rect also works. And yeah, so if we just print out rect3.width, that'll work. But we can also do rect2.width because it should be exactly the same since they got it. But what happens here, we can still again print out rect3.width. And what if we don't want to? I mean, I don't want to. Do you want to? Of course you don't. So let's change this to protected. Protected means that this class can use it, but its children can also use it too. So now this still works, because if we set this to private, then that means only this class could use it, and it's a selfish little dirty class. And these aren't allowed to use it, because this class is being a selfish jerk. So let's change this to protected. So instead of keeping everything to itself, it'll let its children have it, like a good parent should. So now this still works, but if we call this rect3, it's still a not main. I don't know if this should work or not. It shouldn't work. Let me copy this and make a new line out of it, but change it to a rect. Oh, and take the string out of there, of course. Not that. Take the string out and nothing else. Okay. So now if we try to call, rect3.width, which is a rect, this is protected. Don't like that. Let me see. Protected might mean that other packages can't use it. Just to test that, let me just make a new package, mmc.test. When you do .test on packages as well, basically how packages go, you do that, and if you want to make a sub-package, you do dot. I mean, it's not technically a sub-package, it's a completely different package. But if you went into the file system, yeah, if you went into the file system, under it, here we go. This is live, this is for episode 6. Then you go into source, and you go into the file system. There's MMC, which contains all these classes, but it also contains test from mmc.test. So that works. It doesn't have anything in it, but it will soon.